Every configuration manager, regardless of format, needs to do the same things: open a file, parse the contents, validate the result, and return the data. The steps are always the same, only the parsing step differs between JSON, INI, and YAML. This is the template method patterns territory. Define the skeleton of an algorithm in a base class, and let subclasses fill in the specific steps. The base class defines the overall sequence as a template method, a method that calls a series of steps in order. Some steps are implemented in the base class because they're universal. Other steps are declared but not implemented, they're abstract hooks that subclasses must override. The book builds a config template abstract base class with a load method that orchestrates the process. Read the file, call this .deserialize data to parse it, validate the result. The deserialize method is abstract, not implemented in the base class. Every subclass of config template must provide its own deserialize implementation. A JSON config subclass provides deserialize using json.parse. An ini config subclass provides deserialize using an ini parser. Both inherit everything else: file reading, validation, the overall sequencing, from the base class. They only define what's specific to their format. What's the difference between template method and strategy? It comes down to inheritance versus composition. Template method uses inheritance, subclasses override methods. Strategy uses composition, you pass in a strategy object. The book is explicit on this comparison. Template method is more locked, you're committing to a class hierarchy. Strategy is more flexible, you can combine strategies at runtime. Node.js streams use template method extensively. The _read, _write, and _transform hooks are exactly the abstract methods you override in subclasses. Before ES 2015, iterating over custom collections in JavaScript required knowing the internal structure of the collection. Want to traverse a tree? You needed to understand how the tree stored its nodes. Want to read from a custom data source? You needed to know its specific API. The Iterator protocol changed this completely. It defines a standard interface for traversal that any collection or data source can implement, and any consumer can use, without knowing anything about the internal representation. The Iterator protocol: an iterator is an object with a next method. Next returns an object with two properties: value, the current item, and done, a boolean, true when there are no more items. Any code that knows this protocol can consume any iterator. The iterable protocol builds on this. An iterable is an object with a symbol.iterator method that returns an iterator. This is what makes for of loops work. When you write for const item of collection, JavaScript calls collection symbol.iterator to get an iterator, then repeatedly calls iterator.next until done is true. Your custom objects become iterable by implementing this protocol. A range object that generates integers from start to end. A tree that yields nodes in depth first order. A file reader that yields one line at a time. All of these can be consumed with for of, with spread operators, with destructuring, because they speak the iterator protocol. The book demonstrates a custom range iterable, an object that yields integers from a start value to an end value. Once you implement symbol.iterator, the range works with every JavaScript iteration feature automatically. And then generators arrive, making all of this dramatically simpler to write. Writing an iterator manually, maintaining state, returning the right object from next, tracking when to set done to true, is mechanical and tedious. Generators automate all of it. A generator function is declared with function asterisk, function star. Inside it, you use the yield keyword to produce values. When you call a generator function, you don't get the result of the function body, you get a generator object, which is an iterator. Calling next, on it runs the function body until the next yield, returns that value, and pauses. The next call to next resumes from where it paused. The function's own execution stack is the iterator's state. You don't manage a position variable. You don't track what to return next. The runtime suspends and resumes the function for you. The book rewrites the range example as a generator, function asterisk range, start, end, for, let I equals start, I equals end, I plus plus, yield I. That's it. The same range object that required careful state management is now 5 lines of intuitive code. Generators can yield from other iterables using yield star. They can receive values back on each next call as the return value of yield. They can be used as infinite sequences that produce values on demand forever. Async generators take this further. A function declared as async function asterisk can use both await and yield. It produces an async iterator consumed with for await of. This is how you stream data from an API, process database query results lazily, or read a file line by line without loading it all into memory first. The book shows an async generator that pages through API results, yielding each item across multiple HTTP requests transparently. Async iterators are the missing piece for streaming data processing in modern JavaScript. They combine the lazy, on-demand semantics of iterators with the asynchronous, non-blocking nature of Node.js I/O. Consider reading a large file line by line. The synchronous approach loads the whole file. The streams approach is powerful but requires extending a class and implementing _transform. The async iterator approach is straightforward. Use readline.create interface with a file stream, which implements the async iterable protocol. Then write for await, const line of RL, process, line. That's it. Each iteration awaits the next line. Memory stays constant. The file can be any size. And the code looks like a simple loop. The book shows an async generator that paginates through a remote API, function *async create page iterator, URL, let next URL equals URL, while, next URL, const response equals await fetch, next URL, const data equals await response.json, for, const item of data.items, yield item, next URL equals data.nextPage. Callers use for await, const item of create page iterator, /API/items. They see a flat stream of items. The pagination is completely hidden. This is the power that iterators unlock. You can represent any sequence of data, from a simple array to a multi-page API to an infinite stream, with the same interface. Consumer code that works with any iterable works with all of them. For of, spread, destructuring, array.from, promise.all of these work with any iterable automatically. Once you implement the protocol, you get the whole JavaScript ecosystem for free. You've now seen both template method and strategy solve similar problems, defining variable behavior in a fixed algorithm structure. But they represent very different architectural choices, and understanding the trade-off matters for designing APIs. Template method uses class inheritance. The base class defines the algorithm structure. Subclasses override hooks. To add a new format or behavior, you create a new subclass. The algorithm skeleton is locked in the class hierarchy, it can't be changed without changing the base class. This has a specific downside: you can only extend at the granularity of classes. If you need to combine two behaviors, say, a cached version of a compressed transform, you'd need a class that inherits from both, which JavaScript makes difficult, or a class that manually delegates to both. Composition is awkward within the inheritance model. Strategy uses composition. The context holds an interchangeable object. You can combine strategies at runtime. You can build new strategies from existing ones without creating class hierarchies. Strategies are independent objects, they can be tested in isolation, shared between different contexts, and swapped without any code change in the consuming class. Node.js streams demonstrate template method at its best. The _read, _write, _transform hooks define exactly the points where custom behavior belongs, and the rest of the stream infrastructure handles all the complexity. It's the right design because those hooks have a well-defined, non-composable relationship to the stream lifecycle. For most new code you write, strategy is the more flexible choice. Template method shines when you have a well-understood algorithm with specific extension points, particularly when you're building a framework that others will extend. Know both. Use template method for framework-style extension points. Use strategy when callers need runtime flexibility.